All right, more fun with matrices. So let's solve this guy using matrices, and then we'll check with the graphing calculator to make sure that we're doing things the right way. So first, rewrite as the augmented matrix. So we have 1x, 1y, 1z equals 3. On the others, then we have the second equation, 3x, 2y, negative 1. We get 10, and then we have 2x, nope, no x, negative 3, 2 for the z, and then 31. All right. So we notice here that in the first row, first entry, we have a 1. So we're going to use that guy to get zeros below it. And the way we'll do that is that we'll do negative 3 times row 1, add that to row 2, and replace row 2 with that. At the same time, let's do negative 2 times row 1 and add that to row 3 and make that our new row 3. That way we can get zeros for here and here all in the same step. All right, so just be very careful about how we do this. Now, the first row does not change. Let's see about the second row. So we have negative 3 times 1 plus 3 is going to make that 0. Negative 3 times 1 is negative 3 plus 2 is negative 1. Negative 3 times 1 is negative 3 plus the negative 1 makes this negative 4. Negative 3 times 3 is negative 9 plus the 10 gives me positive 1. And then we want to do similar thing with row 1 and row 2. So I'm going to do negative 2 times this plus that, which gives me 0. That's what I was trying to do. Negative 2 times 1 is negative 2, plus negative 3 is negative 5. And then we have negative 2 times 1 plus the negative, or plus 2 is going to give me 0. And then negative 2 times 3 is negative 6, plus the 31 gives me 25. Now, the way that this is written, we could... So there's two things we could do here. We could actually exchange row 2 and row 3. And the reason you might want to do that is because we have that 0 right there, which would be great for the second row. But we don't have to, right? Instead, what we can do is, since we need to get a positive 1 here, multiply everything in row 1 times a negative and replace that row with that. All right, so the first row and the last row do not change. But the second row becomes 0, that's not positive 1, positive 4, negative 1. And now going to that row echelon form, we want to get a 0 underneath this next leading 1. Turn that into a 0. And we'll do that by doing 5 times row 2 plus row 3, and we're going to replace that into row 3. All right. Sadly, a lot of the stuff that we do here with the matrix, with the matrices, is just a bunch of rewriting. And because of that, you've got to make sure that you're very careful as you go from one step to the next. All right, here we go. So 5 times 1 plus negative 5 is 0. And then we have 5 times 4, which is 20, plus 0 gives me 20. 5 times negative 1 is negative 5, plus 25. So negative 5 and 25 is positive 20. See some good stuff here. So we can now do row 3 divided by 20 and replace that into row 3. All right. Again, just a bunch of copying. All right, so we have 0, 0, divide by 20, divide by 20. So right now we're in the row echelon form. And we see at the very bottom that z would equal 1. We could use that back substitute to get y, and then again to get x. So yeah, kind of cool with that. But let's go to that reduced row echelon form and make sure that everything works out. We're going to check with the calculator and make sure that it agrees with us, or that we agree with it. So I need to get zeros here and here. So if I do -4 times row 3 plus row 2, I can replace row 2 with that. And if I do negative row 3 plus row 1 and replace row 1 with that, that's going to get a 0 here. All right, so let's see about that. So the only thing that wasn't changing was my bottom row. Okay, so if I do -4 times this bottom row, and I add it to the one above it. So it's zeros, so that doesn't change those first two guys. -4 times 1 plus 4 is going to give me 0. -4 times 1 plus -1 is -5. And then the top row, I keep the 1 and the 1, and then I do negative this guy, add to that, so that gives me 0. Negative to this, -1, and add to 3, gives me +2. The last thing for me to do is to get a 0 right here, and I'm going to use row 2 for that. So if I do negative row 2 plus row 1, and I plug that into row 1. All right, so let's see. These guys do not change. Got -5, got 1. So I should have 1, 0, 0. So I do negative this plus that is the 0. I negative this plus that, so it's +5 plus 2 makes this 7. So it looks like we have the ordered pair, 7, -5, and 1. Now what you really want to make sure that you do is that you take that and you plug that into all of the original equations and make sure that it comes out right. Okay, it doesn't take long to check that. Let's do that real quick. So if I plug in 7, -5, and +1. 7 minus 5 plus 1 does equal 3. Okay. Here, I've got 3 times 7 plus 2 times -5 minus 1. 21 minus 10 minus 1 is 10. Checks out. And then finally, 2 times 7 minus 3 times -5 plus 2 times 1. So 14 plus 15 plus 2 equals 31. So we know that this is our answer. Let's check with the calculator. So again, let's go to the matrix. So I already have a matrix A here that's a 2 by 3, so that's not good enough. Let's go and edit matrix B. We'll call it a 3 by 4. And for the first one, we have 1, 1, 1, and 3. The second equation is 3x, 2y, -1 for the coefficient of z equals 10. And then we have 2, -3, 2, and 31. Again, we quit out of this. We're going to go to matrix menu, we're going to do the math, and option B is the reduced row echelon form. Again, that's the form that gives us the answer. And we want to choose matrix B. And in reduced row echelon form, it's exactly what we showed. We have 7, -5, and 1 along that right-hand column. And that tells us our solution. Yeah, why can't we always just plug things into the calculator? Well, you need to make sure you understand how to solve it, how to go through that algorithm. Okay, so we have a couple more examples to get through, so yeah, stick around.